Hello everyone. Today we will see in this lecture the transition state theory and bimolecular theory. So let's start. Introduction of a bimolecular theory. The main principle behind this theory is the binary collisions taking place during the gaseous reactions. And according to this theory, all the possible factors must be taken into account for the evaluation of a rate of a reaction. Just like, for example, in gaseous states, the number of molecules taking part must be kept in mind, and at the same time, the energy of the molecule must be known for the interpretation of the reaction. All the factors and the properties related to that mentioned factors must also be considered to establish true picture of the reactions which is taking place. As you can see here, is the number of the collision taking place as well as the nature of the collision must be studied simultaneously. And if we have the two type of molecule denoted by N and N star, which is basically excited molecule, then the rate of a reaction, which is dx divided by dt, will be directly proportional to the N into excited number of the molecule N star. Dx divided by dBdt, rate of a reaction will be equal to Kn N star, and if the reacting molecules are equal to each other, having the same number of molecules of both the reactants, then the reaction equation will be equal to dx divided by dt Kn square. As you can see here, N is equal to N star. So, if E is the energy of activation of a molecule, Z is the number of a binary collision taking part in the reaction per mole per second, and T is the absolute temperature at which the reaction is taking place, while R is a gas constant, and rate of a reaction then will be Z E exponential power and RT. So, this is basically sum up of the bimolecular theory. Start with the transition state theory. Side by side transition theory of absolute rate, which is basically concerned. Transition state theory and the theory of absolute rate of reaction are one and the same thing. In transition state theory, it is believed that the evacuated complex or a transition state compound is first of all formed before the final conversion into the product, see here, and from the other two theories, collision theories of the uni and the bimolecular reactions, where the basic concept was collision between the molecule were responsible for the formation of a product as well as rate of a reaction. But here in this case, transition state theory or a pre-reaction step is involved for the formation of product, and that transition state must be taken into account for the evaluation of an overall nature of the reaction as well as the order of a reaction. Mathematically, if we see two type of a molecule, A and B, taking part in a reaction, and before the formation of a product, the reaction must pass a transition state step as well as has been assumed for the explanation of a transition state theory. Go forward this one, A plus B and transition state, and K will be the rate constant for the product. From this, K is basically is the equilibrium constant, and for the formation of a transition state complex from the reactants A and B, and the rate constant K comes as usual for the formation of a product. It was proposed by Eyring that whatsoever the molecularity as well as the order of a reaction may be followed the equation which can be explained the picture above the such type of a reaction, and which is basically K equal to RT divided by NH K star. So K is equilibrium constant for the first step, other K small k is rate constant for the reaction or the gas constant, T is absolute temperature at which the reaction is taking part, N is Avogadro's number, and other N is Planck's constant. So this is the summary. Go forward. This used for the evaluation of a Eyring equation. From this, delta G is equal to RT in log Ks star excited, and delta G is equal to delta H minus T into delta S, entropy and heat, and there is a relationship of the thermodynamic derivations. If we compare delta G of the both, then this equation is formed, this one. From this equation, go forward and put out the value of log K star, then the value will be delta H minus Ts divided by RT. Proceed this equation. These are basically progressive steps in which the value of delta S and R were calculated, and you can see here, and the value of k star will be exponential power delta s divided by rt and exponential power delta s divided by r. So now put the value of k in the above relationship, and the equation will be turned into in this form. And the equation number, this relationship from which the rate constant may be determined, and also the total heat content as well as change in the entropy of the system can also be explained. Change in the heat of an expression will be by the k equal to RT divided by NH and exponential power. These are another explanation. When delta E equal to delta H, then exponential powers are equal. So from there you can find out the value of Pz, and Z is basically number of Bernoulli. Z is absolutely calculated from this formula 4n square sigma square pi RT divided by m. Here m is the gram molecular weight, T absolute temperature, gas temperature, and diameter of a binary collision is sigma, n is the number of molecules. From here, value of k can be calculated by the formula z exponential power minus e divided by rt by simplifying the above equation, which I already explained. Okay, from here z is basically is the frequency factor. This is the relationship with the help of which we can determine the rate constant during the reaction between the two molecules of gases that fail to explain the reaction where size of a molecule varies, that is increases and overcome this difficulty. So you can calculate the value of K by this formula, and its value is 1 minus 10 raised to minus 9, and oppositely charged molecule can be found out by the 10 raised power 6. So it also depends on the nature as well as the size of the molecule taking part. And in a reaction of by knowing the alternation in the equation, that is after the introduction of a probability factor, the above equation to application to all type of a binary gas reaction taking place under any condition. So there is the sum up and the summary of the today lecture. Hope that you can understand